Hi there. So right now I'd like to just talk about some of the preliminary steps for running MadMiner, either the workflows, either remotely using Rihanna or locally using the yadage workflow engine. So within the tutorial, so this is the kind of main part of the tutorial. The first sections here are about running the notebooks. Locally on using Docker on your machine, but that's not going to scale if you want to do some big analysis. So that's what the Rihanna part's for. So if you scroll down here to MadMiner on Rihanna, this is the section that I'm talking about. So Docker we've already covered a little bit. Yadage is now is this workflow language that's describing basically. You can describe multiple different jobs that you want to run. In principle, each of those jobs can even have a different Docker container associated to them. So for instance, when you're running the event generation part, you don't need PyTorch installed. And when you're running the machine learning part, you don't need MadGraph or Delphis installed. So the workflow allows you to kind of break up the dependencies in the different ways. There's another thing here called MLflow, which is a tool that's useful for basically tracking a bunch of different machine learning runs that you might do. So for instance, if you want to play around with the hyperparameters for the machine learning training or the different network architectures or something like that, or if you just want to, like, say, compare the Sally approach to the Alice's approach, then MLflow will track basically the results of the different runs. Sorry, that's my little puppy that's making noise in the background. It's very sad. Okay, here we go. So this again is the sort of an overview of the workflow, but for right now, what I want to do is talk about the setup. So I am not going to go through the actual running of the jobs on Rihanna because that's already covered in this other video by Arena. So you can read, you can watch this video that goes through the actual submitting of the jobs and seeing what things look like on the cluster and stuff like that. It's basically following the other information that's on in the tutorial here. But what I want to do is talk about setting up the client. So when you run Rihanna again, this is the picture is you have a Rihanna cluster that someone else should have set up. So that would be, for instance, the Rihanna cluster at CERN. But you, as a user on your laptop, you want to submit jobs to the Rihanna cluster. And so the way that works is that you use the Rihanna client. And installing that is very easy. You just go to, literally type pip install Rihanna client. If you're at CERN, if you're going to be running this, like say, instead of submitting jobs from your local machine, you can submit jobs from LX Plus and to the Rihanna cluster at CERN. In that case, you don't even need to install it yourself. You can just type this command from LX Plus, and the Rihanna client will be, is already installed, and then you'll be able to use it. Once you have installed the client, you need to point the client to the particular Rihanna cluster that you're working with. The way that works is pretty easy. You set these environment variables. So the Rihanna server URL goes here. So this would be something like, rihanna.cern.ch. That's this link right here. Unfortunately, you can't see that unless you have a CERN IP address. So I can't demo using the Rihanna instance at CERN because I'm in New York. Okay, but for instance, there is one running at Brookhaven, and also at NYU, we've gotten the IT to set up a Rihanna instance on the green supercomputer that NYU has. So let's see, so you would set the URL to that Rihanna instance. So that would be something like rihanna.cern.ch. And then you get essentially like a login token to kind of have your credentials to know that it's you. And so that gets set in this environment variable called Rihanna access token. You actually find that from when you go to the Rihanna cluster's web page, you have a user profile, and when you click on it, you can see your your access token. And then when you actually go to run, you also need to say the name of the workflow that you're running on. So the workflows, you can name them. In this case, the workflow has been named MadMiner workflow. So you say, you set this environment variable to say that's the workflow that you want to run on. And then this technically should be later on when you actually want to execute it. So this doesn't really need to go here. And then this reana client ping just basically tries to ping the cluster and make sure that the connections are set up fine. So once that part's working, then you can submit your jobs. But the other thing, if you're going to want to monitor the process of the jobs, you'll want to set up a local, you want to set up a connection so that you can monitor that stuff locally. So here's an example. This is using the web browser on your own machine. So it's localhost with this particular port number. In this case, it's 3443. And what that's doing is then kind of piping the web requests to the actual reana cluster. So it's sort of like you have a local thing that's talking to that reana cluster. And so this just sets up that sort of SSH tunnel. So this is the command that's needed to be able to contact the reana cluster at BNL. And then, right. And then again, you set the access token, but that's, would have already been, set there. So, okay, so now, great. Okay, so then you should be able to see this local monitoring. And then the last step, which is something that we would like to try to get rid of, but currently it's still something that we need to do, is that this ML flow is very nice for being able to track different runs. This is I'll just point at it. This is this ML flow package. It's a kind of a industry standard way of one of the different big industry standard ways of monitoring a bunch of machine learning jobs. And so we wanted to integrate that into the reana workflow. But when you do it, when the workflow is running and it's trying to track these metrics, it needs to be able to talk to one of what's called an ML flow tracking server that keeps track of this information. And so right now, for this to succeed, you have to set up your own ML flow tracking server, which you can just run on your laptop. It's quite easy to do. You need to install ML flow, but with Python, that's easy. You just type this line to install ML flow, and then you run the server with these options, and then you've got an ML flow server running on your computer. Okay, so and then when you submit the jobs to the cluster, to the reana cluster will talk back to your computer, and all of these kind of runs will be logged locally, and then you can view them on your web browser and things like that, which is nice. Okay, so so this is getting the ML flow server running, and then when it actually comes time to run the workflows, you also have to set this environment variable, basically setting whatever the URL for your tracking server is. If you're doing it yourself, then this is the value that you would, if you're running your own tracking server, you would use something like that for the URL. Otherwise, you would point it to some kind of public ML flow tracking server, which again, this is something that we're working on to try to streamline this, but this will work. Okay, so great. And then, so those are the preliminaries for the setup for getting reana to run. The next thing that you would do is actually get the workflows themselves. So I'll go ahead and show you this. So the workflow is kind of, how to say it, it's there are 3 different repositories that hold the workflow information. We've split it into 2 different main sub workflows. There's the physics part, which deals with the MadGraph and Pythia and Delphis and stuff like that. And then there's the machine learning piece. And then there's a wrapper for those other 2. And the wrapper doesn't really do much of anything other than call the first 2. so to get all of the workflows, you can type git clone into this line right here, and it points to the MadMiner workflow, and it will also get the sub workflows automatically. So I can sort of demo what that would look like. This thing is still running in the background, so let me open up another one. So I'm going to make a directory called MadMiner, workflows. Okay, and then change into there, change directories into there. Now I can hit copy, paste that, and it's going to clone the actual workflows for me. Okay, and so now if I type ls, okay, MadMiner workflow, that's the name of the repository, so great, so I can go into that, type ls. Okay, there's, this has got the basic stuff, and inside of modules, you'll see the machine learning part and the physics part. And inside of those, so for instance, if I go to MadMiner workflow physics, you see there's the actual code for running the physics portion. So that's where you would have, that's where there's Python files that are similar to the notebooks that we're running. And so let's see, so you see these are the different, Python files for like actually generating things or running Delphis and stuff like that. So they're very similar to the notebooks that we have. But there's also, in this area, there's also a workflow folder, and it has this input.yaml. And if I open that, so I'm going to code is the name of my text editor that I'm using. Okay, then let me bring that over to you. It's opened in a different window. Sorry. I'm having a hard time here. I'll just do it this way. Okay. So this is the workflow file that I just opened for the physics portion, and you see it has the same kind of stuff that we had before in the in the notebook that sets up the parameters that that we want to scan, the benchmark points for the standard model. Here's one other benchmark point. It sets up the morphing tool to be able to choose, to choose other benchmark points, and it sets up the observables and things like that that we're going to be using. So this very much follows the kind of information that you have in the notebooks in the main tutorial. But here you're specifying this information with a YAML file, and the workflow will basically read this information and inject these settings into the Python so that you can actually control it from this sort of configuration file, and it will paste itself into the Python, and then the workflow will run as you desire. So okay, there's a similar workflow for the machine learning part. So if I type input.yaml here, and then what you see, or here you see, I want to train a parameterized classifier with the Alice's and Sally techniques. It talks about setting up running asymptotic limits, the parameter range for the two parameters that we're going to be plotting, kind of how densely they should be scanned. Then it has the setups for training Alice's and Sally, and then it has the parts for doing the evaluation. So in this case, it just looks at the sort of Fisher information, and then some, and then does plotting. There's a plotting script. So so this is really just an example workflow. You would adjust this to do the various different kinds of things that you would like to do, but it's kind of a an example to start with, and it's the one that I showed you that was displayed in that this workflow image. Okay, so so once you have all of that, and I guess if you're doing this tutorial the first time around, you probably don't want to mess with the input file. You probably want to just try to execute it as it is. And then once you confirm that you can execute it like it is, then you might start modifying the input file for, for your purposes. Okay, so there's this page here that describes a little bit more about where you can find the configuration information. And then this last piece here is that if you wanted to execute the workflow. So once you've configured it to do what you want, you can kind of just check this, ping the reana client, use the reana client to ping the server, make sure that everything's fine. And then you can literally just type make reana run because we have sort of all of the other commands and things sort of wrapped up into a make file. So you don't need to know about some of the intermediate steps. It's not very much. You can just look at the make file yourself. And it will submit that to the reana cluster. And then at that point, you can use your local monitor and you can see that that workflow is running. You can click into that workflow and you can monitor like some of the job specification parameters. You can look at all the different files that are being produced locally. You can download those files directly from the web browser. Alternatively, you can use reana client to pull those files from the workspace, but or you can download them from the web browser. You can also access the logs. So for instance, you can just see how jobs are running. You can, if there's an error, you can diagnose them this way to see what's going wrong. And then if there's like, plots and things like that, you can even click on the plots and just like see the plots directly in the browser, which is kind of nice. And then if you've set up one of these MLflow tracking servers and it's sending back results, you can also go to the MLflow tracking server on your machine and you can actually see the results of the different runs and check to see whatever value, whatever quantities that are being tracked. So I should say that when this workflow runs, the thing that's a little bit interesting is that the Docker containers are pre-built, so you don't really need to bother installing anything. And the workflow file is basically, there's already a repository that has a workflow file. So most of what you do is just reconfigure through these YAML files what it is that you want to do, and then run the launch the workflow to the cluster. If you want to do something more, change something deeper, like you want to go in and actually change something about what's being logged, or you're not happy with the Python files and what how they're using MadMiner, and you want to adjust something that you can't do just from the workflow, you can do that. You will need to then build your own Docker containers. That kind of information is described. How to do that. Is described if you go back to here, get the workflow. These are the workflow repositories. So if I go here to MadMiner workflow PH, excuse me, and describes what all is going on. It also talks about how you can build the Docker image. It has like the makefile knows how to build the Docker images with whatever changes you've made to it, and then you can push the Docker images instead of to Docker Hub. You can push them to your own area in Docker Hub, and then you can run this similar kind of workflow, but it would just be with your own Docker containers, and you can customize it however you see fit. Okay, and if you have requests for things that you would like to see as kind of part of the default workflow, then please go to these repositories and just add an issue and make a feature request, and we can try to modify the standard workflow and Docker images to support the kinds of features that you would like. Okay, great. Hi there. So now I'm going to describe about how to run these workflows locally on your computer instead of on reana. So again, this is the tutorial. And if you scroll down to MadMiner on Rihanna, we've gone through a lot of these stages. We talked about how to configure the workflow and how to execute the workflow on Rihanna. And this last part right here is about running it locally. And so the idea is that before you launch a bunch of big jobs on a cluster, you may want to just check that the workflow is running like you think it is, and maybe it's more convenient to be able to develop that workflow and configure it just on your own laptop or something like that. And then once you're ready, you might want to submit it to Rihanna. So in this case, you're not going to get the advantages of having a big cluster, but you can just be a more convenient experience for trying to develop things. So the actual MadMiner workflow is written in a workflow language called yadage. And Rihanna knows how to interpret this yadage workflow and then run it, on a cluster. But you don't need Rihanna to do that. You can, in this case, you can just use yadage directly. So, I'm going to show that. So I'm going to go into this workflow folder that I had created earlier. So all I did was make a directory called workflow. And then I went to this get the workflow. So I just cloned the repository from GitHub. So that's it. That's all I've done at this stage. And then, so I see these different areas. Now, if I want to run it locally, I need to install yadage. Okay. So, so I'm going to hit this, copy this line. Usually when I work, I try to work with, different environments. You can either use Python's virtual env, or I use Conda a lot. So I have an environment called MadMiner. So I'm just going to go into that area, and I'm going to type pip3 install yadage. Okay, so so now I've installed the yadage. Great. And then if I come here, it says now I should be able to run the workflow locally. The workflow is already set up. So all I need to do is somehow tell yadage to run it. And that's already defined as a rule inside of the makefile. So if I type less and look in the makefile, you can see there's a command for running Rihanna, which does the different Rihanna client, creates the workflow, uploads the workflow, starts the workflow. And then there's the same kind of thing for yadage. And so I'm going to, run the workflow with yadage. So I can just type make yadage run, and now it's launching. If you saw in that workflow, I should have shown it. Let's see, I can open it up here. Here's the makefile. You see right here, num generation jobs equals 6. So what this is doing is in the workflow, when you go to generate events with MadGraph and Pythia and Delphis, it's basically saying you have run cards that say how many events you want to generate, and you can just replicate that some number of times. So if you want to generate more Monte Carlo, all you need to do is basically increase this number of generation jobs to be something larger. So when this does it, here it's going to be running 6 jobs. Maybe I should have made that number be smaller. This configuration option is described in configuring the workflow inside of the makefiles rules section. So that's this, and you can when you type make yadage run, you can also specify those arguments with a flag, with a command line flag. Okay, so I launched 6 jobs on my one machine, so maybe that was not the smartest thing to do, but that's what I did. So then if I go here to Docker and look at the dashboard, I see that I actually have 1, 2, 3, 4, 5, 6 6 different Docker containers running that are using the MadMiner workflow PH, for PH is for physics, Docker containers. So my my machine is busy working away, I still have a seventh Docker container running, which was for the main part of the tutorial, which is this kind of interactive approach with where we're doing the workflow kind of by ourselves step by step with a bunch of Jupyter notebooks instead of using either the reana or yadage or the kind of more that workflow based approach. So yeah, so my computer is busy. Maybe you can hear it, the fan spinning along in the background. So that will run, and so that will take a little bit. I will maybe just open another terminal here. So if I go to, so I already ran this actually, okay, yadage just earlier today. So this was the same kind of thing. I go into, there's the workflow area. And if you look here, you don't see much of anything. If I go back to the documentation about running locally, the output of the yadage run is actually stored in this .yadage file in a folder, which is because it has a dot in front, you might not see. So if I type L-A, I can see the .yadage file. If I change into the yadage folder and look around, then I see that both the physics workflow and the machine learning workflow. And if I say go into workflow machine learning, you see the three different training runs that were there. And then there's some, after it's trained, it evaluates the data files, and then there's a plotting stage. So if I go into plotting here, I can see that there's a folder called plots, and there we go. And I can actually, open up all methods.ping and there's the plot that was created. So this, so just by typing this make yadage run, it launched the entire workflow locally on my computer. And in the end, I have the files, right? So this is the same workflow that's going to run when I run it remotely on Reana. It's just instead of running on my local machine, it'll be running on the Reana cluster, and I'll be able to scale it to much many more jobs for generating Monte Carlo. And if I want to do a parameter scan, for the inference, I can do a much denser parameter scan on the cluster than I would be able to do on my own local machine. Also, I'd be able to, for instance, train many different machine learning models with different hyperparameters to try to see how they perform and things like that. Okay, great. So then I will stop there, and that's that. Thank you.